Hello. So we're going to start on area, chapter 10. Most of this here is going to be review. There'll probably be a couple of new concepts for today. But starting with area of a rectangle, obviously that is just base times the height. Big important piece of information for this and all area really is you have to have a perpendicular height. So you see that little square in the corner, and that indicates where your perpendicular height is. It always has to be a perpendicular. Okay, for a square, makes it even easier because the side lengths are the same. So it's s times s, but you also just write that as s squared. Parallelogram. The only thing that people generally get wrong with this, again, the whole base. It's always the whole entire base. And again, you need the perpendicular height. So you are not going to use this slanted height here. You're always going to use the perpendicular height straight up and down with that right angle indicated. Triangle, again, something people get wrong, even though you've done triangle area a long time, is you have to use the entire base length, always. Always use the entire base length. Okay, and then we're using, again, the perpendicular height. But for a triangle, it really is just half of a parallelogram. And you can kind of imagine if you kind of drew this out here and did that, right? This is half of this parallelogram. So that's why you use 1/2 base times height. Okay. All right. These next ones might be you probably just don't remember them, but you've probably talked about them before. But the kite and the rhombus area. So you can actually use diagonals for a kite and a rhombus, and that's because one of their properties for both shapes is that their diagonals are perpendicular. So since their diagonals are perpendicular, we can use the diagonals to find the area. Okay, so this is a formula you just have to use and know. I am going to show you why that works here, but you don't have to write any of this down. Okay, so let me just show you why that works. Let's concentrate just on one of these bigger triangles. So let's look at just this triangle. Well, just that triangle has an area of 1/2 diagonal 2, because diagonal 2 represents the entire length here. And then the height is half of diagonal 1. Okay, so that would be the area of just this triangle. Now you'll notice there's an identical triangle down here. So what you're going to do is take this and multiply it by 2, because there's 2 of those triangles. Okay, and so you could do some fancy cancellation, but basically 1/2 times 1/2 is 1/4, and 1/4 times 2 is 1/2. So that ends up with 1/2 diagonal 1 times diagonal 2. Now you're never going to have to talk me through that or anything. So if you can just remember, this is the formula whenever you have a kite or a rhombus. And again, that's because they have perpendicular diagonals. Okay, trapezoid. So trapezoid, you have 1/2 the height. So this is the height. Again, perpendicular. It has to be a perpendicular height, not this slanted height. So the perpendicular height. And then you multiply that by base 1 plus base 2. Again, the bases are all the way across, and the bases are always going to be the parallel sides. So these are your parallel sides, those are your bases, and then you have your perpendicular height. Okay, and then again, I'm going to talk you through why that works. You don't have to write any of this down if you don't want to, but why that works is, let's pretend like we cut this trapezoid in half. And then we're going to take this top portion and I'm going to rotate it down to this side. So I take this part and I rotate it down here. You can imagine that. Well, now I have these two pieces, so let me highlight that with maybe this yellow. But these two pieces here is just a rearrangement of the trapezoid. Okay, notice that the height here is 1/2 of the original, so it's 1/2 the height. And then this yellow highlighted piece here is a parallelogram, and the base of that all the way across is this base 2, and then when I flip this down, this is base 1. So I do 1/2 the height of that yellow parallelogram, and then base 1 plus base 2 is actually the base length of that parallelogram. So that's why it works, but again, you'll never have to explain that to me, so I'm going to erase this. And you guys are just going to use that formula. Oops, that's not 1/2, sorry. So this is the height, and that's base 2, and this is base 1. So there's your formula for a trapezoid. Okay, let's try some of these. So example 1, a rectangle. If you don't have a picture, you should always draw a picture. So a rectangle, and we have right angles everywhere, that has a perimeter of 44, so all the way around the shape is 44, and a side length of 12. So that means one of these sides is 12. Okay, so I'll just put the 12 here to start. Well, we know that opposites for one of the properties of a rectangle is that opposite sides are congruent. Okay, so then I'm going to put an h here for height. Well, I know this would also be h. So I would have 12 plus 12, which is 24, plus 2h is equal to 44. That's the perimeter. So you can subtract the 24, and you get 2h is equal to 20. So therefore, h is equal to 10. So now that I know h is 10, the area is really easy because I have a perpendicular. You just do 12 times 10. Okay, so that's going to be 120, and then this is inches squared. Okay, area is always in square inches. All right, number 2, same type of concept, but you're doing it with a square. So please pause and try this one by yourself. Okay, welcome back. So you have a square. Always draw the shape. Okay, and I know that the perimeter is 32. And for a square, all of these are the same. So what I would set up is 4s, or s plus s plus s plus s, is equal to 32. So divide by 4, and each of those is 8. So then my area is going to be 8 times 8, or in other words, 64. And again, this is inches squared. Okay, number 3. So we have a parallelogram. Now, just like the rectangle, one of the properties of a parallelogram is that opposite sides are congruent. Because what you'll notice is the right angle here is going to a side that is not labeled. You always want to look for the right angle so you know which base and height, which numbers you're going to use. So we're going to use the property that opposite sides are congruent and label that this side would be 7 and that this side would be 12. So noticing my perpendicular here, you want to use this side as your base, and then the 10 here is your height. So my area is going to be base times perpendicular height. So this one is going to be 70 feet squared. So the important thing, let me box this one. The important thing is wherever the perpendicular is, so identify where that is the base you want to use, and that is the height you want to use. Okay, number 4. So this triangle is actually labeled differently than you're used to probably. So whenever you see these dashed lines outside of the triangle, because the triangle that we're doing is actually just this shaded triangle. This is the triangle we're finding the area of. These dashed lines, you have to try and ignore those. All they're indicating is where this perpendicular height, what base it goes to. Okay, so here's my perpendicular. Again, identify where that is. Here's my perpendicular. So this is the height I want to use. Okay, so the height is going to be 4. And then these dashed lines just indicate that that height corresponds with this base. So my base is simply going to be the 5. Ignore the dashed lines. And then therefore my area is going to be base times perpendicular height. And that would be 20. And if you don't have units, you want to write units squared. Okay, these types of questions do take some getting used to. Okay, rhombus. So a rhombus with diagonals of 8 inches and 6 inches. So I would highly recommend that you always draw yourself a picture if you don't have one. You have to remember what a rhombus looks like. A rhombus has 4 congruent sides, but it's not necessarily a square. Okay, so the diagonals, we would have one guy that's 8. That whole thing is 8. And then this whole thing is 6. These are always going to be perpendicular. Now, the other thing you know about a rhombus is that the diagonals bisect each other. So you could also label it like this. But since I'm given the lengths of the diagonals, I am just going to use my rhombus formula, which says 1/2 diagonal 1 times diagonal 2. And that's it. That's all you have to do. Okay, now you're only going to apply the 1/2 one time. So I can do 1/2 times 8, which is 4, and then 4 times 6. So that's going to be 24, and that'll be inches squared. Okay, last one. So again, the most important thing is to look for your perpendicular. Here's my perpendicular. So that means 12 is the height. Okay, and then I have my 2 bases. And then I'm going to throw that into the formula. So 1/2 perpendicular height is 12. And then in the second set of parentheses here, you do base 1 plus base 2. Right, that's 10. Okay, and then you're going to simplify. Now, in this case, it's easiest if you add those together first. So 1/2, 12 times 30. And then again, you only apply that 1/2 one time. So 1/2 of 12 is 6. And then 6 times 30 is 180. You can always use the calculator. There's no units, so this would be units squared. Okay, those are the basics for area. I'll see you next time.